In this video, we will continue to multiply polynomials together, but we're going to look at one special case of multiplication of polynomials. We call this a special product. Let's look at the 4 examples that I have up here. Let's multiply all 4 of them together and see if we notice any patterns that come out of them. In our first one, when we multiply this binomial, x plus 4, x minus 4, we'll use the FOIL method that we learned in the previous lesson to make sure that we distribute properly. And we'll get x squared minus 4x plus 4x minus 16. And we have to remember to always combine like terms in the end. So our final answer, when we combine these like terms of negative 4x and positive 4x, we get x squared minus 16. Let's quickly use the FOIL method for the other 3 examples as well. After combining like terms, we get our product of n squared minus 25. 2 more examples. Our product is y squared minus 36. And the final example our product is 9x squared minus 4. So the question is, what is the pattern, or what is the trend that we're seeing in all 4 of these multiplication of binomials? And what do our products look like? Well, what we can see in our product is that each one of them results in being a binomial, okay? Because our middle 2 terms in each problem, when we combine them, end up canceling each other out and end up with 0. So we can see that this follows a similar pattern in every single problem. And so we can learn this quick rule for learning how to multiply a sum and a difference of 2 terms. Notice that our a plus b is our sum and our a minus b is our difference. And when we multiply them together, we get our product of the a is squared minus our b squared. And we call this product the difference of 2 squares. So let's look at how to use this little shortcut, this product rule, for how to multiply sums and differences of 2 terms. All 6 of these examples, as you look at them, follow the same general rule. Each binomial has a sum, and it's multiplied with the difference of the same exact term. So we could use the FOIL method, or by looking at our rule on the previous page, we can use a shortcut. We can square our a and then subtract it with our b squared. So in this example, we multiply our x's together to get x squared. That's our a squared. And then we multiply our 3's together to get minus 9. And that is our product. Because if we were to multiply our outer and our inner terms, these would have canceled each other out anyhow. Let's do this a few more times. For number 2, we get 4x squared minus 25. We multiply our a's together, and we multiply our b's together. Example 3, x to the 6th minus 64. Once we learn this rule, we're able to multiply this special case of binomial multiplication quickly together. 16x to the 8th minus x to the 10th. X squared minus 1 over 49, when we remember our rules for multiplying fractions. And lastly, we'll do the same rule using decimals. X to the 4th minus 0.36. And you'll notice that it doesn't matter if the sum comes before the difference or if the difference comes before the sum, the rule still applies. That's just the commutative property of multiplication. Two things to be careful of when you're using the special rule is to make sure that you're always multiplying the sum and the difference of two seemingly identical terms. So look at the first example, x plus 4 times x plus 4. This is not a sum and a difference. Instead, it's two sums. So we can't use our shortcut of the sum and difference rule to multiply these. This is actually a different type of special product that you'll see in the next video. But for right now, you'd have to multiply this one carefully using FOIL in order to get the correct answer. X to the second plus 4x plus 4x plus 16. You'll notice that our middle two terms of 4x and 4x end up being 8x, which is why this is a slightly different type of multiplication problem. And in number 2, it looks similar. Here we have a sum and a difference of two terms, but they're not identical terms since my first term in each of them, one is a 2x squared and one is a 2x. So again, in order to multiply this one correctly, we would have to use FOIL once more.